Hello, my name is Carlos Gómez Cubero. I am from Aalborg University in Denmark, and I'm going to present our work, which is called Intention Recognition in Human-Robot Interaction based on eye tracking. What is the motivation behind our work? Well, in human-robot interaction, we have two agents. We have a human and we have a robot. And they both work in close proximity to do a task together. The robot, at the end of the day, is just another machine with some code inside and needs inputs from the outside to perform their tasks. So, the more inputs, the more data we can gather from the outside, the better. In this case, eye movement is a source of information that the humans give away, and it could be nice to use this information for the robot. If we can somehow find an algorithm that predicts the intention of the human, then the robot can adapt during the task, and then we can get some benefits. For example, we can apply some collision avoidance, we can improve the efficiency by improving the movements of the robot, and so on. In the paper, we try to predict intent from gaze, and to do so, we explore two methods: the Cascade Effect and a machine learning approach using LSTM-based models. At the end, we propose an algorithm for intention recognition using these two methods that use gaze as an input. We designed a data collection using virtual reality and eye trackers. Here in the lab, we have a headset that has some cameras inside and can map where the attention of the participant is inside of the 3D world. So we can log the position of the gaze all over the time. The participants has to complete one task. This task consists in picking one object between three. The objects appear on the table, and the participant has to pick the one they like the most. During the time where the participant is looking, we are logging where the gaze is going. And then when the participant selects one object, we call it signal the object, the robot pick the object and put it in the basket. You can see the representation in the figure. At the end, we have 30 participants and 755 samples to work with. In this slide, we can take a look on the data. In the first figure, we have the gaze path over the table for one of the samples. So we can see how the participant is scanning the table. And in red, we have the object that he signaled in the end. The second figure is a different view of the same sample. In this case, we have as x-axis, we have time, and as y-axis, we have the long side of the table. So these up and downs means that the participant is looking left and right. In the last figure on the right, we have the histogram of the length for each sample. So we can see that more or less for this task, it takes around 5 seconds, maybe between 4 and 8 to complete. There are three different stages when we make decisions based on our vision. First is the orientation. That is when we move and we focus in the region of interest of the task. The second is the evaluation, and it happens when we scan the different possibilities and then we evaluate them. The third is the verification. The verification happens when we want to do something, we want to select or signal one of the objects, and then we do it. But there is this time between my brain says, okay, let's do it, and then I move my hand and touch it. This time frame is the verification stage. And we estimate that is around 1.5 seconds for this task. Let's talk about the different methods we explore. First is the Cascade Effect. It was introduced by Simoyo and their colleagues in 2003, and they state that if you have to select between different objects, the one that receives more attention is going to be more likely to be selected at the end. Also, they say that if you change the exposure of the different choices, the one that gets more time of exposure is also going to be more likely to be selected. In our work, we use the amount of time that the participant is looking at each object to predict which one is going to pick. The other method is the machine learning approach. For this, we use LSTM layers. These layers are very good on predicting and finding features in time series. And as we saw before, the data we have is a time series. The model we used, the topology, is 2 layers of LSTM and 1 layer of fully connected neural network. With this, we can do first a feature extraction and then a classification of these features. We try 2 different data sets. One with the raw data and a second where we truncate the last 1.5 seconds. This 1.5 seconds is where we said before that is the verification stage. In this slide, we can see the accuracy of the different methods. Actually, they perform very good. The Cascade Effect has around 75% and the machine learning model has around 80%, both 2 seconds before the object is signaled. That is actually impressive. And also, the machine learning model that is trained without the verification stage, it performs better over time, as you don't let the machine learning to learn the last part of the interaction when the participant is trying to signal the object. So then it learns other patterns that happen during the interaction. So we will stick to this trained model without the verification stage. But we have a problem here, and that is that this method works perfect, but only when you know the signaling time. So if you try to put this in a real-time interaction when you don't know when the object is going to be signaled, then it's impossible to get a proper results using these methods like this. So for that, we are proposing an algorithm. This algorithm consists in first, the output of the machine learning model, and second, the cascade effect, so the amount of attention that is accumulating one of the objects, and a threshold. This threshold is measured in seconds. So for example, if we have these 3 objects and we look for more than the threshold to one object more than the others, and also the machine learning model is giving me the same output as the object I'm looking, then I'm gonna select this object. But if I'm looking around and the machine learning model is giving me different outputs, until I don't surpass this threshold with the cascade effect, I'm not taking this output. The result of this is that we lose some of the accuracy, but we get a lot less false positives. So in this graph with the dot line, we can see what is the false positives of using the cascade effect and the false positives of using the algorithm with 2 different thresholds, with 0 seconds, so no threshold, and with 0.75 seconds of threshold. So in practice, what we need is an algorithm that gives a single output, and this output is transferred to the robot, so the robot can trigger some action based on that. If we take the very first output of the algorithm, we see what is in the figure that is in front of you. With the blue line, we have the percentage of interaction that has been successfully predicted. So in this case, at the end, 70% of the interaction has been successfully predicted using a threshold of 0.75, and only 15% has been a false positive. What give us in the end is the idea that this method can be used in a real-time interaction without knowing when the object is signaled. What is the current and future work related to this? Well, right now in the HRI lab here, we are our goal is to improve the accuracy and decrease the number of false positives. So we are collecting more data, trying to get a more complex machine learning model, and find time relations within participants. What means that we figure out that some participants are faster and some participants are slower when they make decisions. So this threshold can be tuned per participant and not per task. So then we can get better results. Also, we want to start as soon as possible applying this method to an interaction. So actually the robot can take the initiative and pick the object before the participant signal it. And then make HRI studies and see how people react to this algorithm, because we don't know yet if the participants are gonna feel unsafe or strange. It's something that we will start studying as soon as possible. So thank you very much. If you have any question, this is the moment. Please check our webpage, hri.tech.aau.dk, and if you have any questions, feel free to send us an email to me or to Matthias as well.